8086 microprocessor architecture and pin diagram. A microprocessor is a program controlled semiconductor device which fetches instructions from the memory, decodes, and executes instruction. It is used as a central processing unit in Coming to the first generation of microprocessor, it is between 1971 to 73, which is manufactured with the PMOS technology and non-compatible with the transistor logic. In this first generation, 4-bit microprocessors with the 16 pins and 8 and 16-bit processors with 40 pins are developed. Due to the limitations of pins, signals are multiplexed. Second generation of microprocessors. During 1973, NMOS technology with faster speed, higher density, compatible with the DTL, 4, 8 and 16-bit processors are 40 bits, ability to address large memory spaces and I/O ports, and greater number of levels of subrouting, nesting, better interrupt handling capacity. In this, the Intel 8085 is the main processor under this second generation. Third generation, during 1978, it is manufactured with HMOS technology, faster speed, higher package density, and it is have only 16-bit processors with the 40, 48, and 64 pins and easier to program, dynamically relatable programs. Processor has multiply and divide arithmetic hardware, more powerful interrupt handling capability. The major processor released in this third generation is Intel 8086, which is the first 16-bit microprocessor. Fourth generation during 1980s, it has low power version of HMOS technology, that is HCMOS. 32-bit processors are released. Physical memory space is 2 power 24 is equal to 16 MB and virtual memory space is 2 power 40 is equal to 1 terabyte. Floating point hardware supports increased number of addressing modes. The main important microprocessor released under this fourth generation is 80386 microprocessor, and the fifth generation processors, and the next generation is from till today. The main functional blocks of 8085 microprocessor are ALU, flag register, timing and control unit, register array or internal memory, instruction decoding, program counter. The ALU computational unit which performs arithmetic and logic operations, and flag register checks various conditions and stored as a status bits called flags in the flag register. Internal storage of a data. The program counter generates the address of next instruction to be fetched from the memory and send through address bus to the memory. And the instruction decoding unit decodes instructions, send information to the timing and control unit. The timing and control unit generates control signals for internal and external operations processor. The overview of 8086 microprocessor. It is the first 16-bit microprocessor released by the Intel in the year 1978. Originally, it is manufactured with HMOS technology and now it is manufactured with HMOS 3 technique. Approximately 29,000 transistors are integrated on a single IC, which consists of 40-pin IC, and it requires plus 5 volts power supply. It doesn't have internal clock frequency, and we need to connect externally with asymmetric clock source with 33% duty cycle. The 8086 microprocessor has 20-bit address bus and it can access up to 2 power 20 is equal to 1 MB memory space. The addressable memory space is organized into two banks of 512 KB each, that is even memory bank and odd memory bank. Address line A0 is used to select even bank and and control signal BHE bar is used to access odd bank. Used as a separate 16-bit address for I/O mapped devices can generate 2 power 16 is equal to 64K addresses. It operates in two modes, minimum mode and maximum mode, decided by the signal MN and MX bar pins. Coming to the pins, this is the pin diagram of 8086 microprocessors, which contains 40 pin ICs. 40 pin IC which have three set of pins. Signals which are common in both modes, that is maximum and minimum. Signals have special functionalities in minimum mode and signals have special functionalities in maximum mode. Coming to AD0 to AD15, these are the address bus and data bus signals which are bidirectional. Lower order address bus, these are multiplexed with data to form address and data lines. When the data is transmitted over AD lines, the symbol D is used in place of AD. For example, D0 to D7, D8 to D15 or D0 to D15. A16 to A19 S6 are the higher order address bus lines. These are multiplexed with the status lines S3, S4, S5 and S6. Bus high enable is multiplexed with the status signals S7. It is used to enable the data onto the most significant half of the data bus, that is D8 to D15. 8-bit device is connected to the upper half of the data bus use BHE bar. BHE bar is used to select the odd memory bank. Mn/mx bar are the main important pin in 8086 in order to select the mode of operation of processor. If the mn/mx bar is equal to 0, it is operated in a minimum maximum mode. When mn/mx bar is equal to 1, it is operated in minimum mode. Read bar, it is an active low signal which can be used to read operation. 8086 microprocessor architecture and pin diagram. Reset causes the processor to immediately terminate its present activity. The signal must be active high for at least 4 clock cycles. The clock input provides the basic timing for the processor operation and bus control activity. It has asymmetric square wave with 33% duty cycle. INTR is an interrupt request. This is the triggered input which is sampled at the last clock cycles of each instruction to determine the availability of request. The signal is active high and internally synchronized. NMI. NMI is the non-maskable interrupt and VCC is a supply pin which requires. These are the minimum mode pins. The 8085 can work in two modes of operation, that is minimum and maximum mode. In the minimum mode of operation, the 808586 microprocessor do not associate with any coprocessors and cannot be used for microprocessor systems. In the maximum mode, the 8086 can work in a multiprocessor or coprocessor configuration. Minimum as maximum mode operations are decided by the pin mn/mx bar. When this pin is high, 8086 is operated in minimum mode and otherwise it is operated in maximum mode. Pins 24 to 31 is for minimum mode of operation and mn/mx bar is tied to VCC. 8086 itself generates all the bus control signals DT/R bar, data transmit and receive. It is a output signals from the processor to control the direction of data flow through the data transit, data and receivers. When DT/R bar is equal to 0, receive operation and DT/R bar is equal to 1, transmit operation. DEN bar, data enable, is the output signal from the processor used as an output enable for the transceivers. ALE, address latch enable, is used to demultiplex the address and data lines using external latches. M/IO bar is used to differentiate memory access and IO access. For a memory reference instructions, it is high. For in and out instructions, it is low. WR bar is itself active low signal, that is write control signal, assert low whenever processor writes the data to memory or IO port. INTA bar is an interrupt acknowledgement signal when the interrupt request is accepted by the processor. The output is low. Hold is an input signal to the processor from the bus masters as a request to grant the control of bus, usually used by DMA controller to get the control of bus. HLDA acknowledgement signal to the hold request. The acknowledge is asserted high when the processor accepts the hold. During the maximum mode of operation, the mn/mx bar is grounded, that is logic low, and the pins 24 to 31 are reassigned. S0, S1 and S2 are the status signals used by the 8086 bus controller to generate bus timings and control signals. When the S2 and S1 and S0 are zeros, interrupt acknowledgement in order to read IO port 001, 010 for write IO port, 011 for halt, 100 for code access, 101 for read memory, 110 for write memory, 111 is for passive. QS0 and QS1 are the queue status signals. The processor provides the status of the queue in these lines. The queue status can be used by external device to track the internal status of the queue in 8086. The output of QS0 and QS1 can be interpreted as shown in the table. When the both QS1 and QS0 are zeros, no operation is performed. 01 first byte of opcode from the queue, 10 empty the queue, 11 subsequent byte RQ and GT not bar, bus request and bus grant signals. These are request are used by the other local bus master to force the processor to release the local bus at the end of the processor's current bus cycle. These pins are bidirectional. The request on GT0 will have higher priority than GT1. Lock, an output signal activated by the clock prefix instruction. The 8086 output low on the lock pin while executing an instruction preferred by the lock to prevent other bus masters from gaining control of the the architecture of 8086 processor. This is the architecture of 8086 microprocessor. The total architecture is divided into two units, bus interface unit and execution unit. Bus interface unit consists of address generation, segment registers, instruction pointer, instruction queue, and the execution unit consists of general purpose registers, offset storage registers, ALU, and flag register. Bus interface unit fetches instructions, reads data from the memory and I/O ports, and writes data to memory and I/O ports. Execution unit executes the instruction that have already been fetched by the bus interface unit, and bus interface unit and EU functions separately. Dedicated adder to the 20-bit address, and these are the four 16-bit segment registers that are support segment, data segment, stack segment, and extra segment registers are performed either overlapped segments and non-overlapped segments. 8086 is a 1 megabyte memory is divided into 64 kilobytes each. 8086 can directly address 4 segments, that is 256 kilobytes within 1 megabyte of memory at particular time. Programs obtain access to code and data in the segments by changing the segment register contained to point to the code segment register is a 16-bit register which contains the base or start of current code segment, and IP contains the distance or offset from this address to the next instruction byte to be fetched. Bus interface units computes the 20-bit physical address by logically shifting the contents of code segment 4 bits left to and then adding the 16-bit content of IP. Data segment register is a 16-bit register which points to the current data segment. Operand from the most instructions are fetched. 16-bit contents of source index and destination index or 16-bit displacements are used as an offset for computing the 20-bit processor. This is the architecture of 8086 microprocessor. The total architecture is divided into two units, bus interface unit and execution unit. Bus interface unit consists of address generation. Extra segment register is a 16-bit register points to the extra segment in which data is stored. String instructions uses the extra segment and DA instructions to determine the 20-bit physical address for the instruction pointer is a 16-bit register which always points to the next instruction to be executed within the currently executing the code segment. In general, instruction point cannot be used as a general purpose registers while programming, and instruction pointer is generally referred as the program counter. A microprocessor is a program controlled semiconductor device which fetches instructions from the memory, decodes, and executes instruction. It is used as a central processing unit in execution unit decodes and executes the instruction. A decoder in the execution unit controls and translates the instructions. 16-bit ALU for performing arithmetic and logic operations, and 4 general purpose processors, 2 stack pointer and base pointer, and 2 offset storage registers, source index and destination index registers. AX can be used as both 2 8-bit registers AH and AL like BH, BL, CH, CL, and accumulator register consists of two 8-bit registers AL and AX. And AL is a lower order byte of the word, and AH is higher order byte. The IO instructions use AX and AL for inputting and outputting the 16-bit or 8-bit data from IO ports. Multiplication and division instructions also use the AX and or AL for default BX register is also called as base register, which have two 8-bit registers, lower byte BL and higher byte BH. All memory references utilizing this register content for addressing the DS as the default segment. CX is a counter registers which have two 8-bit registers CH and CL, and which can be used especially in shift, rotate, and loop instructions as a counter. The instruction loop start automatically decrements the CX by 1 without affecting the flags, and it repeats the loop operation until the counter becomes. A microprocessor is a program controlled semiconductor device which fetches instructions from the memory, decodes, and executes instruction. It is used as a central processing unit in stack pointer and base pointer are used to access the data in stack segment. SP is used as an offset from the current segment SS, and SP contents are automatically updated due to the execution of a pop and push. Source index and destination index are used in index addressing. These instructions can process the data strings, use the SI and DI registers together with the data segment and extra segment respectively in order to distinguish between the source and destination. Flag register of 8085 as it is a 16-bit flag register where it consists of 9 active flags. Carry flag. The flag is set when the carry forwarded from D7th bit to D8th bit. Parity flag is set to 1 if the lower byte of if the lower byte of the flag register contains even number of ones. It is set odd number of ones set to 0. Auxiliary flag is set when the carry forwarded from D3 bit to D4th bit. Zero flag is set if the result of ALU is 0, it is set, and the result of ALU is non-zero, it is reset. Sign flag. This flag is set when the result of any computation is negative. Trap flag is set when the processor enters into a single step execution. Interrupt flag is set when 8086 recognize any external mask. Direction flag is set when it is used in string manipulation instructions. For auto incrementation mode, that is CLD, which is used as an instruction CLD, direction flag is set. For STD, set direction flag is set to 1. It is then the strings are in auto decrementing mode. Or sign flag, this flag is set when the result of any computation is negative. Overflow flag. This flag is set if an overflow occurs. If the result of a signed operation is large enough to accommodate in the destination register, then the overflow occurs. The result is more than the 7 bit in case of 8 bit, then we can set the overflow flag, otherwise it is 8086 categorized into 4 groups: general purpose registers, pointer registers, index registers, instruction pointer, segment. This is the registers with its name and special function.